This is a fully working intercom system built with relays, power supplies, and zero microcontrollers. I won't tear this apart today. Instead, I'll explain how the system is designed so you can adapt it.
There you go. There you go. Real magic happens in here. These relays go to these micro limit switches. So if one is hung up and the other one is off the hook, you push the button and then a relay makes. This one will switch from DC to AC and send it to this timer right here. And like the old school days, pick it up. There you go. And you can talk. You can talk. Thank you.
At a high level, this system allows two stations to communicate using standard touch-tone phones. When a button is pressed, power is routed through relays to generate a ring signal. When the handset is lifted, relays switch the audio path, creating a two-way intercom. Here's what went into the build. I'm not listing quantities to copy. This is about understanding roles. Amazon affiliate links are available in the description. For power, a 120 volts alternating current to 24 volts, direct current power supply, and a 120 volts alternating current to 12 volts, direct current power supply. The controls are 2 NO push buttons, 2 8-pin relays, 12-volt direct current coils, 2 14-pin relay, 24-volt direct current coil, 1 timer relay, 2 micro limit switches, 1 1000 microfarads, 100 volts capacitors, 2 4.7 microfarads, 100 volt capacitors, 1 100 microfarads, 100 volt capacitor, 2 1/4 watt, 20 ohm resistors. Communication components include ring generator, 2 phone jacks, 2 1990s, touch tone phones. All of this in an enclosure with power cord and cord grip. This system intentionally separates voltages. The 120 volts AC stays isolated inside the enclosure. 24 volts DC controls all logic and relays, and the 12 volts DC powers the ring generator. Relays are doing all the thinking here. Buttons energize coils. Contacts reroute power and audio. Let's discuss a few things here. Normally open versus normally closed behavior. These terms describe the button or relay contact when not engaged. In a normally open button, power does not go through the button until pushed. This is common for start buttons in industrial machinery. As for a relay, it determines what path the signal or voltage follows when the relay is not on. In a normally closed circuit button, power goes through the button when not pushed, most common in stop buttons. In the relay, the power takes a different path when the coil is engaged. For this project, the 2 push buttons are normally open so they can energize the 24-volt DC relays. The contacts on the relays have both normally open and normally closed to direct the voltage where it needs to be at a certain time. Why different coil voltages? As stated earlier, the push buttons engage the 24-volt DC relays. It's now standard control voltage. However, the phones are wired in series with each other and the 12-volt DC relays. When one phone is picked up, one relay engages. When the second phone is picked up, the circuit is complete and both relays are engaged. Why relays? They're simple, cheap, and easy to repair and troubleshoot. Microcontrollers are more sophisticated, but for a home automation project, relays are perfect. When a call button is pressed, the timer relay activates the ring generator. The phone rings until answered or timed out. When the first phone is picked up, the first 12-volt DC relay engages and starts to open the path of communication. At the same time, the micro-limit switch is disengaged, which gives 24-volt DC power to the push button. When the button is pressed, the 24-volt DC relay engages, which turns on the timer relay. The timer relay is set to pulse. The ring generator can go on and off, like it was before the days of smartphones. Handset lift changes the state of the second 12-volt DC relay, which both connects the circuit to allow communication and turns off the timer relay. Old touch-tone phones are perfect for this. They're rugged, cheap, and electrically simple. Are there improvements I would make? Of course! No system is perfect, especially the first time around. First of all, I would use a larger enclosure. This was one I used on another project that I improved on, but a larger enclosure would give more room for the components and more room to work. Second, I would put the push button on the handset instead of the enclosure, again utilizing what I had. But having the button on the actual phone is more realistic. I will still have links to items I use, but you can do it how you like. It's now your project. If you want to see a wiring walkthrough or a schematic breakdown, let me know in the comments. Make sure to like, comment, and subscribe, and visit our Instagram account. You can also support the channel by shopping via the Amazon affiliate links and visiting our Printify pop-up. Thanks for watching. Remember, creativity is evidence of a creator.